Welcome to Study Loop.
We need to find the tension at this point B whenever the value of h is 5 meters. And to solve this problem, we're going to use this equation here. And the only unknown is the y of b, this y of b length. So we're gonna solve for this y of b length and plug it into this equation, and that will give us our tension. So to start, we know that the length y of b can be found by c, the length c, times the hyperbolic cosine of the length x of BD divided by c. And this length x of BD, we can find this by taking the length 10 and dividing it by 2, and that will give us a length of 5 meters. And we can also write that y of b is equal to the length h plus the length c. So we equate these two expressions. And we plug in h, and we can plug in x of BD. So we plug in h, and we plug in x of BD. And we're left with an equation that we can solve for c. And after we solve for c, we get a value that's equal to 3.094 meters. So we can now take this value and plug it into this term here, solve for y of b, since we already know what h is. So y of b is going to be equal to 5 plus value of c, and that will give us a length of 8.094 meters. And we know that the tension is equal to the weight per unit length times the length y of b. So the tension is equal to 0.4 times 9.81. Since we're given the mass per unit length, so we do times 9.81 to get the weight of that value, and then times y of b, and this will give us a tension that is equal to 31.8 newtons.